Hi, uh, in this video, we are going to learn about data discretization using K-means technique. Okay, so for that, here we are generating some data, 3000 data points using Gaussian or normal distribution coming from three different distributions with different means and standard deviation. We are doing that for visual and clarity purpose, easy to understand, but the data don't have to be this way. Okay. All right. So here we have the timestamped the raw features, and let's look at how our raw data is. Okay. So we have 3000 data points. Now these are the values. So the first one is again coming from a normal distribution with a mean of 50 and the standard deviation about 10. And the second one probably mean of 10 and standard deviation is 50. So the mean is somewhere here. And because the standard deviation is slightly higher, you can see the spread of the data is also high. And the third distribution, the mean is 170 and the standard deviation is 20, which is even higher than the second one. So that's why you see this spread, wider spread here. Okay, so we have this data. Again, for demonstration purposes, we have this almost clearly separable data, but in real world, we might not have that. Okay, so the K-means is a machine learning technique to cluster the data into different number of groups. But here we need to inform the model how many groups we want to divide the data into. Now we might not know what's the best value for that. There are other techniques to find out the optimal number of groups. But let's say we have already did that analysis and we know 3 is the optimal number of groups for this data set. So what we do is we call this K-bin discretizer from scikit-learn. We are saying, okay, I wanted 3 bins and I wanted to use the K-means algorithm for grouping or dividing the data. Okay. Here we have only a single feature, but this model expects a data frame or two-dimensional array. So here we are simply reshaping it to multi-dimensional or two-dimensional array. Okay. So at this point, we are only doing the fit. If you know scikit-learn, you probably know this language, fit and transform. So when we do the fit, we learn the task, whether it is training an ML model, which in this case we are training an ML model. And then when we do the transform, we actually apply what we learn during the fit to the data. So we do the fit on the training data, then we can apply the transform on training data, test data, or validation data, etc. Okay. All right. So here we learned how to divide the data into 3 bins. And now we are applying for each data point which bin the data belongs to. Okay. And it also returns this two-dimensional array. So here we are flattening it to get back this one-dimensional array. Okay. So this is our feature. This is the raw data, and this is the bin number. So it starts with 0. So 0, 1, and 2. So this array will take only 3 values, 0, 1, and 2, because we have asked only for 3 bins. Now let's look at how the data is divided into 3 bins, right? So these are the bin edges. So the first bin values lie between this 23 to 73. The second bin values lie between 73 to 132, and the third bin values lie between 132 to 233. Okay, so we are doing some plotting. This is the histogram of raw data. This is our actual data. Now this vertical line represents these 4 boundary values we have discussed. So the given the data in this blue color, the model has divided into 3 groups with the boundaries. So the first group values lie between values this and this, and the second group values lies between this and this, and the third group values lie between this and this. Now, if instead of histogram, if we look at the raw values as it is, So here we have the raw values, the 3000 raw values, and the first group values are between these two horizontal lines, and the second group values are between these two, and the final group values are between these two. So it seems like model has done a pretty good job. Now uh, the points in the middle, those are clearly assigned to the groups they should be, and because of this overlap we have some points, for example, I mean these points, even though they are generated as part of the second group, but clearly they belongs to the first group, right? So the model is able to divide this data clearly into three bins. Okay, that's how the K-means. That's how we can use the K-means algorithm to cluster the data into different groups, and we can use the group ID / bin number as a feature as well. Okay, thank you.